Okay, so let's do some review about factoring. Now, I realize that most of you actually make mistakes about the perfect square trinomials. So let's do a little bit reviewing perfect square trinomial. Okay. So if you recall, for every number a and b, you would have, if I have a squared plus 2ab plus b squared, this will be equal to a plus b times a plus b, and this one will be equal to a plus b squared. Okay. The same situation with a squared minus 2 times a times b plus b squared, and in this case we would have a minus b times a minus b, and that this will equal to a minus b squared. Okay. So for example, I would have something like this. Now, I will have x squared plus 8x plus 16. Okay. And you realize that this is actually, x squared here is already square. 16 is actually 4 square, right? And now we have a and b. So I have a is x, b is 4. Now 8x here can be actually written as 2 times, okay, a as x and b is 4. Okay, so 2 times x times 4 exactly equal to 8x. Okay, so I would have equal to, this one would equal to x plus 4 square. Okay, so another example would be 4n squared minus 12n plus 9. Remember here, actually 9 is 3 square, right? So I know that my b is 3. Have a look at this, 4n squared. Now, we know that this is actually a square, right? So we already have we have already n here. We can actually rewrite this as 2n squared, right? And this will be my a. So my a would be 2n. Alright? So what happened here is that how about 2n here, 12n here, okay? So 12n here would be equal to 2 is actually default here, times a, which is 2n, times b, which is 3, okay? And we know that 2 times 2 is 4, 4 times 3 is 12n here, okay? So I can rewrite this as 2n, because this is a minus sign, so minus b, which is 3, and this is square. Okay, so this is actually a perfect square trinomial. Now, we have to recognize that the perfect square trinomial, first thing is that the first and the last terms are perfect square. So the first and last term here, remember that a square and b square here has to be in perfect square. What it means is actually, remember that the last example we have 4n squared, and it has to be the full square here. Okay, so it has to be rewritten as 2n squared. Same with 9n squared, right? So you have to rewrite this as something square, right? And 9 we know that it's a 3 square, so it's 3n squared here. Okay, and the middle term here, okay, is twice the product of one factor from the first term and one factor from the last term. What it means is actually, if I have, so it means actually it's double, okay, of the product of A and B. Alright, so that is one example. Let's do another example for this. Okay, so let's say that I have 4x squared plus 20x plus 25. Okay, so I know that the first one is I can write this as 2x and square. Alright, the last term I can write it as 5 square. Now, the middle I need to check it if this is a double of the product of the first term and the last term. So I have that 2 times 2x times 5, and yes, this is actually equal to 20x. So this one I can write it as 2x plus 5 square. Okay, alright. Now, another one is actually, some of you make a lot of mistakes, is the factoring a difference of 2 square. Okay, factoring a difference of 2 squares, and what it means is actually simple like this. A squared minus b squared would be equal to a minus b times a plus b. Okay, a lot of textbook actually it writes a plus b here first. Okay, and then times a minus b. But I highly recommend you to actually write a minus b first, because this term will actually give you the order of a and b. Whereas here, because a plus b, you can actually written as b plus a. But here, you can actually, you can actually from here, a minus b, you can find the order of the term. So for example, I have the x squared minus 64, okay, and I know that x squared is already, this is the first square. 64 is what? 64 is 8 squared, okay, and this equal to x minus 8 times x plus 8. Okay. Another example would be 25x squared minus 36. Okay, so this is a little bit tricky, but don't worry about it. Now, you see x squares, and a lot of people actually forget about 25. What would happen to 25? We know that 25 can be written as 5 squared, right? So this is 5x squared. Okay, so you need to actually put it into the perfect square form. Minus 36 is 6 squared here, and this will be equal to, remember the a minus b, so my a is 5x, my b is 6 times 5x plus 6. Okay, so this is a pretty good example for this. Now, another way of factoring is actually by grouping. Okay, and this is an example that we had on the exam, on the test. We have 3n cubed minus 12n squared plus 2n minus 8, and you need to factor it out. Okay, so the first thing what we do is actually factor out the GCF of each group of terms. Okay. So what happened is actually you see that there's a similarity here. Okay. The first group, if you group this two terms and group this together, okay, you would have that 3. Okay, so the GCF for this first group would be 3n squared. Okay, and the GCF for the second group would be only 2. Okay, so let's say the first group, what we have for first group, we have 3n squared. Okay, and 3n squared here. So if we factor out 3n squared inside, it would still have only n. Okay, and 3n squared here. So 12n squared divided by 3n squared, right? Remember the GCF. The GCF for this one is actually 3n squared. So by factoring out means that you divide this. Okay, so 12n squared divided by 3n squared would be equal to 4. Okay, right, 3n squared, 12n squared, okay, and this divided together with 4. Alright, and now here plus the GCF for this one would be 2. Okay, so I put 2 out. Inside the bracket would be n minus 4. Okay, and now I know that actually this one is n minus 1. N minus 4 is the common factor here. So I would factor out n minus 4 again, and I would have 3n squared plus 2. Okay, this is the final answer for it. Let's do another example. So I have 4q to the 4th power minus a cube plus 12q squared minus 24q. Okay, and I need to factor this out completely. So I realized that's actually what's the common here, the common in term of the term. So actually every single term here, it has q. Okay, so this one we have q. First is common. The next common thing is actually all of this number can be divided by 4. Okay, so the greatest common factor for these all 4 terms is actually 4q. And then if you divide this by 4q, you would have q to the 3rd power. Okay, so this is q minus 2q squared plus 3q minus 6. Okay. Is it done? Not yet. Because actually if you can see, if you group these together, okay, you would know that this is, if you put q out, you would have q squared minus 2. So actually, if you put q squared here, okay, so if you put q squared here out, you would have q minus 2, and if you put 3 out, you would have q minus 2. Okay, another opportunity for us to actually do the common factor. So we would have 4q here out, and then you would have q minus 2 as a common factor, and inside would be again q squared plus 3.